The field of robotics has undergone remarkable transformation in recent decades, evolving from simple machines designed to perform repetitive, mundane tasks into sophisticated systems capable of executing complex functions with high levels of autonomy. In the early stages, robots were limited to specific, programmed operations within controlled environments such as factories, where they were used primarily to replace human labor for tasks that were repetitive or physically strenuous. These early robots were typically programmed to perform the same actions over and over again with little or no flexibility, and their role was mainly in improving manufacturing efficiency by increasing output while reducing the potential for human error. However, as technology progressed, the capabilities of robots expanded, and they began to perform tasks that went beyond basic automation. The introduction of advanced technologies such as artificial intelligence, AI, machine learning, and sensors has drastically improved robots' ability to perform a range of operations in real time, making them more adaptable, autonomous, and able to learn from their surroundings. The integration of AI and machine learning into robotics is a key factor in this shift. Robots are no longer limited to executing pre-programmed instructions. They now have the capacity to understand their environment and make decisions based on data input. This leap in technological advancement has allowed robots to perform tasks in a variety of industries beyond manufacturing, including healthcare, logistics, and even customer service. In healthcare, for instance, robots are being used to assist in surgeries, help with patient monitoring, and even administer medications. These advancements are helping medical professionals by improving precision in surgeries, reducing human error, and enhancing patient care. In logistics, robots are becoming central to automating supply chains, with autonomous machines being used for warehouse management and product delivery, speeding up processes and reducing costs. These applications showcase the ways in which robots are not just limited to repetitive industrial tasks but are becoming essential in sectors where precision, safety, and efficiency are critical. Another remarkable aspect of the future of robotics is the development of robots that can interact more naturally and intuitively with humans. Early robots were isolated from human interaction, functioning as standalone machines that performed their tasks in isolation. However, as AI has become more advanced, robots are now able to recognize human emotions and respond in ways that make them more relatable and effective in human environments. This is evident in the growing use of robots as personal assistants or companions, especially for the elderly and individuals with disabilities. For instance, robots are being developed to provide companionship, assist with mobility, and even help with daily tasks such as fetching objects or reminding individuals to take medication. These robots are not simply tools but are becoming more integrated into daily life, offering both functional and emotional support. Such innovations in robotics are set to change how people interact with technology, making robots more integral to personal care and social interaction. In the workplace, robots are poised to play an increasingly collaborative role alongside human workers. In the past, robots were primarily seen as replacements for human labor, particularly for tasks that were hazardous or physically taxing. However, modern robotics focuses on collaboration, with robots designed to work alongside humans in shared spaces. These collaborative robots, or cobots, are designed to safely work with humans, assisting with tasks such as assembly, inspection, and packaging. This shift allows robots to take on the more repetitive and strenuous tasks, freeing up human workers to focus on higher-level decision-making and creative work. Additionally, cobots can be used in dangerous environments, such as construction sites or chemical plants, where they perform tasks that would be risky for humans. This type of collaboration is transforming industries, improving both efficiency and safety, and it is expected to become even more prevalent in the coming years. Robots are also making their way into more personal, everyday applications, such as home automation and domestic care. Robots like automated vacuum cleaners, lawnmowers, and even personal assistants are becoming commonplace in homes, offering convenience and improving quality of life. These robots are equipped with sensors and AI, allowing them to navigate complex environments and adapt to their surroundings. As AI advances further, robots will become even more capable, learning individual preferences and routines to provide more personalized assistance. In the future, robots may assist with a wide range of household tasks, from preparing meals to offering companionship, providing both functional and emotional support to people of all ages. These advances represent a future where robots play a central role in improving the daily lives of individuals, particularly in the context of caregiving and companionship for older adults or those with special needs. While the potential of robotics is vast, it also presents significant challenges, particularly in the ethical and societal realms. As robots become more autonomous and capable, questions surrounding their decision-making abilities and accountability come to the forefront. In sectors such as healthcare or autonomous driving, robots may be responsible for making life-or-death decisions, raising concerns about the ethical implications of such actions. Additionally, as robots take on more tasks traditionally performed by humans, there are worries about job displacement and the potential for increased inequality. Automation could lead to a shift in the labor market, where many jobs are replaced by robots, creating economic and social challenges that need to be addressed. Ensuring that robotics benefits all of society will require careful planning and policymaking, including retraining programs for workers displaced by automation and measures to ensure that the advantages of robotics are shared equitably. The rapid development of robotics offers numerous opportunities, but it also necessitates careful consideration of its impact on society. The future of robotics is not just about machines performing tasks. It is about creating a future where robots are integrated into society in ways that enhance human life. As robots become more capable and integrated into various industries and daily activities, the key challenge will be to balance the promise of innovation with ethical considerations, ensuring that robotics is used to improve quality of life and solve global challenges. With careful planning, the integration of robotics can lead to a future where machines and humans collaborate seamlessly, opening up new possibilities and improving efficiency, safety, and productivity across industries. The field of robotics has undergone remarkable transformation in recent decades, evolving from simple machines designed to perform repetitive, mundane tasks into sophisticated systems capable of executing complex functions with high levels of autonomy. In the early stages, robots were limited to specific, programmed operations within controlled environments such as factories, where they were used primarily to replace human labor for tasks that were repetitive or physically strenuous. These early robots were typically programmed to perform the same actions over and over again with little or no flexibility, and their role was mainly in improving manufacturing efficiency by increasing output while reducing the potential for human error. However, as technology progressed, the capabilities of robots expanded, and they began to perform tasks that went beyond basic automation. The introduction of advanced technologies such as artificial intelligence, AI, machine learning, and sensors has drastically improved robots' ability to perform a range of operations in real time, making them more adaptable, autonomous, and able to learn from their surroundings. The integration of AI and machine learning into robotics is a key factor in this shift. Robots are no longer limited to executing pre-programmed instructions. They now have the capacity to understand their environment and make decisions based on data input. This leap in technological advancement has allowed robots to perform tasks in a variety of industries beyond manufacturing, including healthcare, logistics, and even customer service. In healthcare, for instance, robots are being used to assist in surgeries, help with patient monitoring, and even administer medications. These advancements are helping medical professionals by improving precision in surgeries, reducing human error, and enhancing patient care. In logistics, robots are becoming central to automating supply chains, with autonomous machines being used for warehouse management and product delivery, speeding up processes and reducing costs. These applications showcase the ways in which robots are not just limited to repetitive industrial tasks but are becoming essential in sectors where precision, safety, and efficiency are critical. Another remarkable aspect of the future of robotics is the development of robots that can interact more naturally and intuitively with humans. Early robots were isolated from human interaction, functioning as standalone machines that performed their tasks in isolation. However, as AI has become more advanced, robots are now able to recognize human emotions and respond in ways that make them more relatable and effective in human environments. This is evident in the growing use of robots as personal assistants or companions, especially for the elderly and individuals with disabilities. For instance, robots are being developed to provide companionship, assist with mobility, and even help with daily tasks such as fetching objects or reminding individuals to take medication. These robots are not simply tools but are becoming more integrated into daily life, offering both functional and emotional support. Such innovations in robotics are set to change how people interact with technology, making robots more integral to personal care and social interaction. In the workplace, robots are poised to play an increasingly collaborative role alongside human workers. In the past, robots were primarily seen as replacements for human labor, particularly for tasks that were hazardous or physically taxing. However, modern robotics focuses on collaboration, with robots designed to work alongside humans in shared spaces. These collaborative robots, or cobots, are designed to safely work with humans, assisting with tasks such as assembly, inspection, and packaging. This shift allows robots to take on the more repetitive and strenuous tasks, freeing up human workers to focus on higher-level decision-making and creative work. Additionally, cobots can be used in dangerous environments, such as construction sites or chemical plants, where they perform tasks that would be risky for humans. This type of collaboration is transforming industries, improving both efficiency and safety, and it is expected to become even more prevalent in the coming years. Robots are also making their way into more personal, everyday applications, such as home automation and domestic care. Robots like automated vacuum cleaners, lawnmowers, and even personal assistants are becoming commonplace in homes, offering convenience and improving quality of life. These robots are equipped with sensors and AI, allowing them to navigate complex environments and adapt to their surroundings. As AI advances further, robots will become even more capable, learning individual preferences and routines to provide more personalized assistance. In the future, robots may assist with a wide range of household tasks, from preparing meals to offering companionship, providing both functional and emotional support to people of all ages. These advances represent a future where robots play a central role in improving the daily lives of individuals, particularly in the context of caregiving and companionship for older adults or those with special needs. While the potential of robotics is vast, it also presents significant challenges, particularly in the ethical and societal realms. As robots become more autonomous and capable, questions surrounding their decision-making abilities and accountability come to the forefront. In sectors such as healthcare or autonomous driving, robots may be responsible for making life or death decisions, raising concerns about the ethical implications of such actions. Additionally, as robots take on more tasks traditionally performed by humans, there are worries about job displacement and the potential for increased inequality. Automation could lead to a shift in the labor market, where many jobs are replaced by robots, creating economic and social challenges that need to be addressed. Ensuring that robotics benefits all of society will require careful planning and policymaking, including retraining programs for workers displaced by automation and measures to ensure that the advantages of robotics are shared equitably. The rapid development of robotics offers numerous opportunities, but it also necessitates careful consideration of its impact on society. The future of robotics is not just about machines performing tasks. It is about creating a future where robots are integrated into society in ways that enhance human life. As robots become more capable and integrated into various industries and daily activities, the key challenge will be to balance the promise of innovation with ethical considerations, ensuring that robotics is used to improve quality of life and solve global challenges. With careful planning, the integration of robotics can lead to a future where machines and humans collaborate seamlessly, opening up new possibilities and improving efficiency, safety, and productivity across industries. As technology progresses at a rapid pace, industries across the globe are increasingly turning to automation to streamline their operations, boost efficiency, and reduce operational costs. Robotics, at the forefront of this transformation, is playing an essential role in reshaping how industries operate. The application of robotic systems is no longer confined to manufacturing lines but has expanded into sectors such as logistics, agriculture, and construction. In these industries, robots are performing a wide variety of specialized tasks, such as assembling products, moving goods, and managing complex operational workflows. The scope of automation is only expected to grow as robots become more advanced, transitioning from performing simple repetitive tasks to being capable of learning, adapting, and improving their performance over time. This shift will result in robots being able to take on an even broader range of roles across different industries, increasing their overall versatility and efficiency. The widespread adoption of automation is not simply about replacing human workers with machines. Instead, it is about optimizing workflows and augmenting human capabilities. By allowing robots to handle repetitive, physically demanding, or hazardous tasks, businesses can free up human workers to focus on activities that require cognitive skills, creativity, and critical thinking. The human workforce can shift towards roles that involve problem-solving, complex decision-making, and innovation, activities that robots, despite their increasing intelligence, are still unable to perform effectively. This shift in task allocation has the potential to greatly increase workplace productivity and create opportunities for humans to engage in more fulfilling and intellectually stimulating work. For example, robots can handle tasks like assembling parts on a factory floor, packaging products, or managing inventory in warehouses, while human workers focus on strategic decisions, quality control, and process optimization. One of the most significant impacts of automation will be seen in industries where workers are exposed to dangerous conditions. Professions in fields like deep-sea exploration, mining, and hazardous waste management often require workers to operate in environments where human life is at high risk. Here, robots are set to play a crucial role by performing tasks that would otherwise be too dangerous for humans. For instance, robots can be deployed in deep-sea exploration to gather data and perform maintenance on underwater equipment, avoiding the risks associated with human divers. Similarly, in mining operations, robots can handle tasks like drilling or transporting materials, which would be hazardous in such volatile environments. The ability of robots to operate in extreme or hazardous conditions not only ensures safety for human workers but also contributes to more efficient and cost-effective operations by minimizing downtime and preventing accidents. While the impact of automation in industries like manufacturing and mining is already significant, automation is also set to extend its reach into sectors that are less traditionally associated with robotics. For example, in healthcare, robotic systems are increasingly being used to streamline administrative processes, assist in surgeries, and support patient care. Robots in hospitals can help with tasks such as distributing medication, assisting with routine patient monitoring, and even providing physical therapy. This type of automation has the potential to improve patient outcomes by increasing the accuracy of diagnoses and treatments, while also freeing up medical professionals to focus on higher-value tasks that require their expertise. In retail, robots are already being used to manage inventory, track customer preferences, and even assist with checkout processes. These robots can work tirelessly around the clock, reducing the need for human labor in menial or repetitive tasks and improving overall customer experience. The rise of automation is also making its presence felt in the logistics sector, where robots are revolutionizing supply chains and transportation systems. Autonomous robots are increasingly being used in warehouses to move goods, sort packages, and fulfill orders with great precision. These robots can communicate with each other and adapt to changing conditions, ensuring that goods are delivered efficiently and without error. Additionally, in transportation, self-driving trucks and drones are being developed to transport goods more efficiently, potentially reducing the cost of logistics while improving delivery times. These advancements in logistics automation are not only making supply chains more efficient, but are also creating new opportunities for innovation in industries such as e-commerce, where speed and reliability are essential. As automation becomes more widespread, its impact on the economy and job market will continue to grow. On one hand, the increased use of robotics is expected to lead to higher levels of productivity and create new industries focused on developing and maintaining robotic systems. Automation allows businesses to scale their operations more effectively, increasing production capacity and enabling them to offer better products at competitive prices. This growth in efficiency has the potential to boost the economy by lowering costs for consumers and driving innovation. On the other hand, there is a growing concern that automation could lead to job displacement as robots take over tasks traditionally performed by humans. This is particularly true in industries where human labor is already being replaced by automated systems, such as manufacturing and logistics. However, while some jobs may be displaced, automation is also expected to create new opportunities in sectors like robotics development, data analysis, and system maintenance, leading to the creation of new markets and industries that didn't exist before. As we continue to move forward into a more automated future, there is a need for businesses and governments to work together to address the challenges posed by automation. While robotics has the potential to drive significant economic growth and improve the quality of life in many sectors, it is crucial that the transition to a more automated world is done in a way that is inclusive and beneficial for all members of society. This includes ensuring that displaced workers have access to retraining programs and opportunities for new employment, as well as establishing frameworks to address the ethical considerations surrounding the widespread use of robots in industries. As robotics continues to evolve, it is clear that automation will become an integral part of nearly every industry, driving efficiency, innovation, and growth across sectors while also presenting challenges that must be navigated thoughtfully. The healthcare industry is undergoing a profound transformation, driven by advancements in robotics. Medical robots, once relegated to assisting in highly specialized surgeries, are now expanding their role across a wide spectrum of healthcare tasks. These robots are proving to be invaluable tools, offering increased precision, reducing risks, and improving outcomes in various medical procedures. The integration of robotics into healthcare has the potential to revolutionize not just the way surgeries are performed, but also the overall approach to patient care, diagnostics, rehabilitation, and disease prevention. As technology continues to advance, robots are becoming essential in helping healthcare providers address some of the most significant challenges facing the industry, including rising patient numbers, the increasing complexity of medical conditions, and the shortage of healthcare professionals. One of the most notable ways in which robotics is transforming healthcare is through the enhancement of surgical procedures. Surgical robots, such as the Da Vinci surgical system, have already been used in a wide range of surgeries, from urology to orthopedics to cardiovascular procedures. These robots offer unparalleled precision and control, allowing surgeons to perform complex operations with greater accuracy than traditional methods. Robotic-assisted surgeries are minimally invasive, which means smaller incisions, reduced pain, and faster recovery times for patients. This shift toward minimally invasive procedures has numerous benefits, including reduced risk of infection, shorter hospital stays, and less scarring. As these robotic systems continue to evolve, it is expected that their capabilities will expand further, enabling them to assist in even more types of surgeries and making these procedures more accessible to a broader population of patients. The role of robots in healthcare extends far beyond the operating room. AI-powered robots are increasingly being used to assist with medical diagnostics, providing doctors with tools that can analyze complex data and suggest potential diagnoses with remarkable accuracy. For example, robots equipped with machine learning algorithms can analyze medical imaging data, such as X-rays, CT scans, and MRIs, to identify signs of diseases like cancer, heart conditions, and neurological disorders. These robots are not intended to replace doctors, but rather to assist them by offering insights based on vast amounts of medical data that might be difficult for humans to process on their own. This ability to process large datasets and identify patterns that may not be immediately apparent to human clinicians can lead to faster, more accurate diagnoses, ultimately improving patient outcomes. In addition to diagnostic tasks, AI-powered robots could also play a crucial role in predicting future health issues, enabling early intervention before conditions become more serious. As the global population ages, the demand for healthcare services is increasing, creating pressure on healthcare systems worldwide. Robotics has the potential to address this growing need, especially in the context of caring for elderly individuals. Robotic assistants could provide essential support for seniors who struggle with daily activities such as bathing, dressing, eating, and moving around. These robots can be equipped with sensors and AI to monitor the health of elderly patients, ensuring that they receive the proper care and attention even when human caregivers are not present. In addition to helping with mobility and basic daily tasks, these robots can also assist with medication management, ensuring that elderly patients take the correct medications at the right times, which is crucial for managing chronic conditions and preventing complications. Furthermore, robots can offer companionship to elderly individuals, helping to alleviate feelings of loneliness and isolation, which are common among seniors. Robots equipped with social capabilities can engage in conversations, provide emotional support, and even offer entertainment, improving the overall quality of life for aging individuals. These robots can also be connected to telemedicine systems, allowing healthcare providers to remotely monitor patients and intervene if necessary. The growing use of robots in elderly care represents a significant shift toward more personalized and compassionate healthcare, as robots can cater to the specific needs of each patient while offering support and comfort. Another key advantage of robotics in healthcare is the potential to reduce human error, which remains a significant concern in medical procedures. Even highly trained professionals can make mistakes, especially when faced with complex or high-pressure situations. The precision and consistency of robotic systems, combined with AI algorithms that analyze vast amounts of medical data, can significantly reduce the likelihood of errors in diagnoses, treatments, and surgeries. For example, robotic systems used in surgery can provide real-time feedback on a patient's vital signs and adjust the procedure accordingly, minimizing the risk of complications. Similarly, in diagnostic settings, robots can assist in the analysis of medical data, ensuring that no detail is overlooked. By reducing human error, robots can help improve patient outcomes and contribute to more efficient healthcare systems overall. The shortage of healthcare professionals, particularly in underserved areas, is another challenge that robots can help address. In remote or rural locations where access to doctors and nurses is limited, robots can play a vital role in providing care. Telemedicine robots, for example, can connect patients with healthcare providers remotely, allowing consultations to take place even when doctors are not physically present. Robots can also assist in performing routine tasks, such as measuring vital signs or administering basic treatments, freeing up healthcare workers to focus on more complex cases. This ability to extend the reach of healthcare services through robotics has the potential to make a significant difference in areas where medical resources are scarce, ensuring that patients in remote or underserved regions have access to the care they need. As robotics continues to evolve and integrate into the healthcare system, it is clear that robots will become an essential part of the healthcare workforce. From performing surgeries with enhanced precision to assisting in diagnostics, rehabilitation, and patient care, robots are helping to address some of the most pressing challenges in healthcare today. While the integration of robots into healthcare systems raises important questions about ethics and the role of technology in patient care, it is undeniable that the benefits they bring, improving accuracy, efficiency, and patient outcomes, make them a powerful tool in the ongoing transformation of the healthcare industry. As robots continue to evolve, their role in healthcare will only expand, opening up new possibilities for improving the quality of care and enhancing the patient experience. Robotics is rapidly transforming the transportation sector, with self-driving vehicles and drones at the forefront of this revolution. These technologies have the potential to reshape how people and goods move around the world, offering solutions to some of the most pressing challenges in modern transportation. From reducing traffic accidents to improving efficiency, autonomous vehicles and drones are poised to offer a new era of safer, more sustainable, and more accessible transportation. As these technologies continue to evolve, we can expect to see profound changes in how transportation systems function, with widespread implications for industries, cities, and daily life. Self-driving vehicles, also known as autonomous vehicles, AVs, represent one of the most highly anticipated applications of robotics in transportation. Autonomous vehicles are equipped with a variety of sensors, cameras, and artificial intelligence, AI, algorithms that allow them to perceive their surroundings, navigate roads, recognize obstacles, and make decisions in real time without human intervention. This technology has the potential to revolutionize the way people travel, offering a safer, more efficient, and more convenient alternative to traditional human-driven vehicles. With the ability to make decisions based on vast amounts of data, self-driving cars can react faster to traffic situations and avoid accidents caused by human error, which is responsible for the majority of traffic collisions today. Studies suggest that the widespread adoption of self-driving vehicles could significantly reduce traffic accidents, potentially saving thousands of lives each year. In addition to improving safety, self-driving vehicles also have the potential to make transportation more sustainable. Autonomous vehicles are equipped with systems that can optimize routes, reduce fuel consumption, and improve fuel efficiency. By driving in a more predictable and coordinated manner, self-driving cars can reduce the amount of time spent idling in traffic, decrease fuel consumption, and lower emissions. This shift toward more efficient transportation could play a significant role in addressing environmental challenges, particularly in urban areas where air pollution and congestion are major concerns. Moreover, self-driving vehicles are expected to contribute to a more seamless and optimized transportation experience, enabling smarter traffic flow, reduced congestion, and more efficient use of existing infrastructure. As autonomous vehicles continue to mature, we are likely to see their widespread adoption across various forms of transportation, including cars, trucks, and buses. This expansion could have far-reaching effects on the transportation industry, from altering the way goods are delivered to changing the structure of urban mobility. For instance, autonomous trucks are already being tested for long-haul freight transportation, promising to increase efficiency in the logistics sector. With the ability to operate around the clock without the need for rest breaks, autonomous trucks could help address labor shortages in the trucking industry while reducing delivery times and costs. Similarly, self-driving buses could provide more flexible and cost-effective public transportation options, potentially transforming how cities manage their transit systems. Beyond self-driving vehicles, drones are another area where robotics is having a significant impact on transportation. Drones, or unmanned aerial vehicles, UAVs, have already begun to revolutionize industries such as package delivery, surveillance, and infrastructure monitoring. Companies like Amazon are already exploring the use of drones for rapid, last-mile delivery, providing consumers with faster shipping options while reducing congestion on the roads. Drones are also being used for tasks such as monitoring wildlife, inspecting power lines, and surveying construction sites, helping industries gather data more efficiently and at a lower cost. The development of flying cars and autonomous aerial taxis represents the next frontier in drone technology, with the potential to transform urban transportation and offer faster, more flexible travel options within cities. Flying cars and aerial taxis could help alleviate some of the most pressing issues facing urban transportation, such as congestion and overcrowded public transit systems. These vehicles would operate in the air, bypassing the congestion on the roads and providing a faster, more direct route from one point to another. In densely populated cities, Autonomous aerial taxis could provide an alternative to traditional taxis and rideshare services, offering faster travel times and greater convenience. These vehicles could also help reduce the reliance on ground-based infrastructure, which is often expensive and difficult to expand in growing cities. The development of flying cars and aerial taxis is still in the early stages, but with ongoing advancements in drone technology and autonomous systems, this futuristic mode of transportation may become a reality sooner than expected. Despite the immense potential of robotics in transportation, the integration of autonomous systems into the transportation sector presents several challenges. One of the most significant obstacles is the development of regulatory frameworks and safety standards that can ensure the safe operation of autonomous vehicles and drones. Governments and regulatory bodies must work to create laws that address issues such as vehicle certification, traffic laws for autonomous vehicles, and airspace management for drones. Additionally, questions surrounding liability, insurance, and data privacy must be addressed to ensure that autonomous systems operate transparently and responsibly. Another challenge is public acceptance. Many people are still skeptical of autonomous vehicles and drones, particularly when it comes to safety and trust in the technology. As with any new technology, there is a need for education and outreach to ensure that the public understands the benefits and limitations of robotics in transportation. Testing and deploying these technologies in controlled environments, as well as involving the public in the development process, will help build confidence and foster greater acceptance. Despite these challenges, the benefits of robotics in transportation are undeniable. Autonomous vehicles and drones offer the potential to make transportation safer, more efficient, and more sustainable, while also opening up new opportunities for innovation and growth. As robotics continues to evolve, we can expect to see even more advanced autonomous systems that can tackle a wider variety of tasks and offer new solutions to the challenges facing the transportation industry. From self-driving cars to flying taxis, robotics is set to play a major role in shaping the future of transportation, offering new ways to travel, deliver goods, and move people across the globe. The future of robotics holds exciting possibilities, especially when it comes to human-robot interaction and collaboration. As robots evolve to become more intelligent, adaptive, and intuitive, they will not only act as machines performing specific tasks, but also as partners in various fields, working alongside humans to enhance productivity and solve complex challenges. This shift from robotic tools to collaborative partners in human endeavors will have a profound impact on industries ranging from healthcare and construction to customer service and therapy. By complementing human skills, robots have the potential to augment human capabilities and significantly improve outcomes in many domains. One of the key areas where human-robot collaboration is expected to make a major impact is in healthcare. In the operating room, for example, robots are already assisting surgeons with minimally invasive procedures, providing the precision necessary for complex surgeries. Surgeons can rely on robotic systems to enhance their dexterity and control, allowing them to operate with greater accuracy and less risk to the patient. However, while the robot provides the technical precision, the surgeon remains the critical decision-maker, overseeing the entire procedure and ensuring that the patient's needs are addressed with care and empathy. This balance between the robot's capabilities and the human touch ensures that patient care remains at the forefront of the procedure. In the future, the collaboration between robots and healthcare professionals could expand even further, with robots performing more routine tasks such as diagnostics or patient monitoring, allowing doctors and nurses to focus on more complex or compassionate aspects of care. Similarly, in the field of construction, robots have the potential to work alongside human workers to build complex structures with greater speed and accuracy. Construction sites can be hazardous, and many tasks involve physical labor that could lead to accidents or injury. Robots, with their precision and ability to work in dangerous environments, can take on tasks that are repetitive, strenuous, or risky for human workers. This collaboration can not only increase the efficiency of construction projects but also reduce the likelihood of workplace accidents. Robots could be responsible for tasks such as bricklaying, welding, or material transportation, while human workers focus on more complex tasks that require creativity and problem-solving. This division of labor, where robots handle the more mechanical and physically demanding tasks, allows humans to engage in more intellectually stimulating aspects of the job, while still benefiting from the increased productivity robots bring to the process. The potential for collaboration extends beyond the workplace into personal and social contexts as well. As robots become more adept at understanding and responding to human emotions, their role in everyday life will evolve in meaningful ways. With advancements in artificial intelligence, AI, and machine learning, robots will be able to interpret non-verbal cues such as facial expressions, body language, and tone of voice. These emotional intelligence capabilities will enable robots to interact with humans on a deeper level, making them more effective in environments that require a sensitive, empathetic approach. For example, robots could be employed in educational settings, helping students with learning disabilities by offering personalized tutoring or support. These robots could adapt their teaching methods based on the emotional and cognitive needs of individual students, creating a more engaging and supportive learning environment. Similarly, robots could play a vital role in therapy and caregiving. For individuals who are elderly or have disabilities, robots could act as companions, offering emotional support and reducing feelings of loneliness or isolation. By recognizing and responding to the emotional states of individuals, robots could offer comfort and companionship, ensuring that people feel valued and understood. This form of collaboration between humans and robots could improve the quality of life for many individuals who require ongoing care but might not have access to human companions or caregivers at all times. In therapy settings, robots could assist in providing cognitive or physical therapy exercises, guiding patients through routines while offering encouragement and support. This collaborative dynamic would ensure that both the emotional and physical needs of patients are met, while freeing up human caregivers to focus on more complex tasks. As robots become more capable of collaboration, there will also be an increased focus on designing robots that are not only functional but also empathetic. This requires a careful consideration of how robots are integrated into society and how they interact with humans. Ethical concerns will inevitably arise as robots take on more active roles in human lives. For example, questions will emerge about how robots might affect human relationships, both in the workplace and in personal settings. Will people become overly reliant on robots for companionship? Can robots genuinely replace human touch and connection? These are critical questions that will need to be addressed as robots become more commonplace in various aspects of daily life. Additionally, considerations about the ethical treatment of robots will need to be explored, especially as robots become more sophisticated and appear to have more human-like qualities. Despite these concerns, the potential benefits of human-robot collaboration are immense. Robots can bring a wide range of capabilities to enhance productivity, improve safety, and foster emotional well-being. As robots learn to collaborate with humans in more complex and meaningful ways, they will contribute to more efficient workplaces, better patient care, and a more emotionally supportive environment for individuals in need. As these technologies continue to develop, it will be important to strike a balance between the benefits of collaboration and the need for human touch and empathy. When designed and integrated thoughtfully, robots can become valuable partners in human endeavors, amplifying human potential and improving quality of life across various domains. The future of human-robot interaction and collaboration is bright, with endless possibilities for innovation. Whether in healthcare, education, or personal care, robots have the potential to be far more than just tools. They can become partners, collaborators, and companions. As technology advances, these partnerships will become even more integral to our daily lives, transforming the way we work, learn, and care for one another. With careful consideration of the ethical and societal implications, the collaborative future of humans and robots promises to offer great benefits, enhancing both productivity and emotional well-being for individuals and society as a whole. As robotics technology advances, it brings with it not only immense potential, but also a set of ethical considerations that must be carefully examined. These considerations span a wide range of issues, from the impact of robotics on employment and social inequality to privacy concerns and the responsible use of autonomous systems. While the development of robotics can significantly enhance productivity, safety, and efficiency, it also presents unique challenges that society must address in order to ensure the technology benefits all people and does not exacerbate existing societal issues. One of the most significant ethical concerns related to robotics is the potential impact on employment. As robots increasingly take over tasks traditionally performed by human workers, many fear that large sectors of the workforce will face displacement, leading to significant job losses. This is particularly evident in industries such as manufacturing, transportation, and retail, where robots are already performing tasks such as assembly, delivery, and inventory management. Automation is expected to increase productivity and reduce operational costs for businesses, but it can also create a situation where workers find themselves out of a job, unable to compete with robots that are faster, more efficient, and cost-effective. This could lead to unemployment, social unrest, and growing economic inequalities, especially if workers are not provided with the necessary training and resources to transition into new roles. The challenge of ensuring that displaced workers are supported during this transition is crucial. As robots assume more functions, there will be a need for reskilling programs, job retraining, and educational opportunities that equip workers with the skills needed to thrive in a more technologically advanced world. Governments and businesses must collaborate to develop strategies that promote workforce development and minimize the negative consequences of automation. Moreover, policies that encourage the creation of new job opportunities in emerging fields, such as robotics maintenance, AI development, and technology-based services, could help offset the loss of jobs in more traditional sectors. If handled effectively, these efforts could lead to a more adaptive and resilient workforce, reducing the risk of social inequality and ensuring that the benefits of automation are shared more broadly across society. Beyond employment, privacy and safety are critical ethical issues tied to the rise of robotics. Autonomous systems, such as drones and surveillance robots, are already being used in various industries for tasks like monitoring infrastructure, delivering goods, and even conducting security surveillance. However, this technology also raises concerns about the erosion of personal privacy, as individuals could be constantly monitored by robots equipped with cameras and sensors. Governments and corporations may be able to use these technologies for mass surveillance, raising significant questions about how much control people have over their personal data and the boundaries of acceptable use for robotic systems. To mitigate these concerns, it is essential to establish strong ethical guidelines and regulations surrounding the use of robots in sensitive areas such as surveillance and security. The privacy of individuals must be protected by creating policies that limit the scope of data collection and define clear boundaries for its use. For instance, any robot used for surveillance should be required to adhere to strict standards of accountability and transparency, ensuring that its actions are properly monitored and subject to public oversight. Similarly, robotics technology used in military or law enforcement applications must be developed with careful attention to ethical standards, including respect for human rights, the prohibition of excessive force, and the prevention of misuse. Establishing these regulations early on will help ensure that robotics technology is used ethically and responsibly, without infringing on personal freedoms or privacy. The potential misuse of robotics is another area of concern, especially as autonomous systems become more capable of making independent decisions. Robots equipped with advanced AI can be programmed to perform tasks without human intervention, but the ability to make decisions without human oversight could have unintended consequences. For instance, autonomous robots deployed in military settings or law enforcement could make life or death decisions without adequate ethical reasoning, potentially resulting in harm or violations of human rights. Similarly, robots used in consumer-facing applications, such as healthcare or education, may inadvertently perpetuate biases or make unethical decisions based on flawed algorithms or incomplete data. As robotics technology continues to advance, it will be important to integrate ethical decision-making frameworks into the development process of these systems. This could involve incorporating principles of fairness, transparency, and accountability into the programming of AI-powered robots. Developers must prioritize ethical considerations alongside technical specifications, ensuring that the robots they design align with human values and respect ethical principles. Moreover, the use of robotics should always be accompanied by rigorous oversight, testing, and continuous monitoring to identify and address potential ethical issues before they become significant problems. In addition to addressing employment and privacy concerns, there is also the challenge of ensuring that the benefits of robotics are widely distributed across society. Currently, there is a significant divide between those who have access to cutting-edge technologies and those who do not. In order to ensure that robotics benefits all people, not just a select few, it will be essential to create policies that promote equitable access to these technologies. This includes ensuring that businesses and industries adopt robotics in ways that do not disproportionately favor large corporations at the expense of small businesses or low-income workers. Furthermore, international collaboration will be necessary to ensure that robotics development and access are not confined to wealthy nations, but rather are available to people around the world, helping to bridge the digital divide and promote global economic equality. Ultimately, the future of robotics must be shaped by ethical considerations that guide its development and integration into society. While robotics holds great promise for improving productivity, safety, and quality of life, it also raises important questions about employment, privacy, safety, and the equitable distribution of benefits. By proactively addressing these challenges through thoughtful policymaking, collaboration, and responsible innovation, society can harness the power of robotics to create a future that is both technologically advanced and socially just. This will require careful consideration, transparency, and a commitment to ensuring that robotics serves the needs and well-being of all people, both now and in the future. The future of robotics holds incredible promise, poised to shape many aspects of human life. Over the next few decades, we will witness a transformation in how we work, live, and interact with technology. Robotics is already making its mark across various sectors, from healthcare to transportation, and will continue to redefine how tasks are performed and how problems are solved. As these technologies evolve, robots are becoming smarter, more autonomous, and capable of performing tasks that were once unimaginable. While there are still significant challenges to overcome, particularly around ethical considerations and the societal impact of widespread automation, the benefits of robotics are poised to have a far-reaching and positive influence on the world. In healthcare, robots have already begun to change how we approach patient care, surgery, and diagnostics. Surgeons are now able to perform more precise, minimally invasive procedures with the help of robotic systems, improving patient outcomes and reducing recovery times. Robots are also assisting in remote patient care and rehabilitation, providing support for the elderly and people with disabilities. With the continued development of AI-driven medical robots, there is the potential for significant advancements in personalized medicine, making healthcare more tailored to individual needs. The future of healthcare will rely heavily on robots to not only assist in surgeries, but also to enhance patient experiences and improve quality of life for people in need of medical care. Similarly, in transportation, robotics is set to revolutionize how we travel and transport goods. The development of self-driving vehicles promises to make roads safer by reducing traffic accidents and fatalities caused by human error. These vehicles will be able to communicate with one another and adapt to real-time traffic conditions, making transportation more efficient and less prone to congestion. Furthermore, the rise of drones for delivery and surveillance is transforming logistics, enabling faster and more cost-effective shipping options. In the future, autonomous aerial taxis and flying cars could drastically reduce travel time and ease the burden on crowded urban infrastructure. The widespread adoption of autonomous vehicles will not only enhance the transportation industry but also reduce environmental impact by improving fuel efficiency and reducing carbon emissions. The rise of industrial automation is another area where robotics will play a critical role. Automation in manufacturing and other industries, such as construction and logistics, will help improve productivity, reduce human error, and lower costs. Robots can perform tasks that are dangerous or physically demanding, such as working in hazardous environments or lifting heavy objects, reducing the risk of injuries to human workers. Furthermore, robots will assist with repetitive tasks, freeing up human workers to focus on higher-level problem-solving, creativity, and innovation. The future of work in these industries will not be about replacing human labor, but about enhancing human capabilities through collaboration with robots, leading to more efficient and safer workplaces. Perhaps one of the most exciting aspects of robotics is the potential for human-robot collaboration. As robots become more intuitive and emotionally intelligent, they will be able to interact with humans in ways that were previously thought to be reserved for science fiction. Robots could become companions, mentors, and assistants, offering support in a variety of environments. In the workplace, robots could serve as collaborative partners, helping humans perform complex tasks that require precision and expertise. This collaboration could extend into areas such as education, therapy, and entertainment, where robots could assist in teaching, offer emotional support, or even entertain. The future of robotics is one in which robots will no longer be just tools, but active partners that enhance human lives in meaningful ways. However, the future of robotics also brings with it significant ethical challenges. As automation becomes more widespread, there will be concerns about job displacement and the impact on employment. The integration of robots into the workforce raises important questions about how workers can transition into new roles and whether current social systems can accommodate these shifts. Additionally, the ethical implications of robotics extend beyond employment to issues such as privacy, safety, and accountability. For example, how can we ensure that autonomous systems, like drones and self-driving cars, make ethical decisions? How do we protect the privacy of individuals in a world where robots are constantly monitoring and interacting with us? Addressing these ethical concerns will be crucial in ensuring that robotics contributes positively to society, rather than exacerbating inequality or infringing upon individual rights. The impact of robotics on society will also be shaped by how it is implemented. It will be essential to create policies, frameworks, and regulations that promote the responsible development and deployment of robotic technologies. Governments, businesses, and academic institutions will need to collaborate to create a future in which the benefits of robotics are widely shared, and the challenges it presents are addressed in a thoughtful and inclusive way. This might include initiatives to reskill workers, ensuring equitable access to advanced technologies, and establishing ethical guidelines for the use of autonomous systems. By doing so, society can ensure that robotics is developed in a way that maximizes its positive impact and minimizes potential risks. Ultimately, the future of robotics is one filled with both promise and responsibility. As robots become more intelligent and integrated into our lives, they will help address some of humanity's most pressing challenges, from healthcare to climate change. However, we must approach this transformation with care, considering the ethical and social implications of these technologies. With thoughtful planning, responsible development, and a focus on collaboration, robotics has the potential to create a better, more efficient, and more connected world, one in which humans and robots work together to achieve shared goals. By leveraging the full potential of robotics, we can build a future that benefits everyone, improving lives, enhancing productivity, and fostering a more sustainable and harmonious society.
Thanks for watching. Please like, share, and subscribe for more updated videos.